Hi and welcome to this tutorial. Here I'm going to talk about something called as BeanPostProcessors. BeanPostProcessors are classes that tell Spring that there is some processing that Spring needs to do after initializing the bean, hence the name BeanPostProcessors. What happens is when you write some code in your Bean post processor, then Spring executes that code after initializing each and every bean. So this is something that you can use in order to extend the functionality of Spring. So say you want the framework to do something, to perform some actions after bean initializations, then you can write a bean post processor, and then Spring is going to execute that piece of code when every bean is initialized. So a couple of significant points about the bean post processor. First of all, the method, the single method, runs for every initialization of every bean in your Spring XML. So no matter how many beans you have, no matter how many types of beans you have, if I open my Spring.xml, now I have triangle beans and I have point beans, each of a different class. So no matter how many types of beans you have, when every bean is initialized, then the bean post processor method is called. It's the first point. The second point is that the bean post processor is a separate class, obviously, because it caters to initializations of different types of classes. So you have to have a code in a common place. So there is a separate class, and the method of that class runs on initialization of all the different beans in your Spring XML. Now, in the previous tutorial, we saw about init and destroy methods. We saw how we can write a method that gets run on initialization of a bean and on destruction of a bean. The thing is that you're supposed to have that method inside the corresponding class itself. So if you want a method to get run on initialization of the triangle class, the method needs to be inside this triangle class. If you want a method to get run on initialization of the point class, then that method has to be inside the point class. So when you think about that, bean post processor seems to be a very good way to have a method that needs to be run. Say you want a method that needs to be run across all these different types of classes. You want an init method, then it makes sense to put it inside the bean post processor. Most common and the recommended usage of a bean post processor is to extend the functionality of the framework. You might make some configuration related coding in the bean post processors. In this tutorial, I'll show you how you can write your own bean post processors, and in the subsequent tutorials, we'll see some of the out of the box bean post processors that Spring provides. So the use case that I'm going to do here is I'm going to write a class with a method that prints out the bean name, and I want the bean name to be printed out after every bean in my Spring XML is initialized. So what I do is I write a method to print the bean name and I put it in a bean post processor, and then I define the bean post processor in Spring so that Spring knows that it's there. Then what's going to happen is when Spring initializes each of these objects, it's going to call the method of that bean post processor, and of course each of these bean names are printed. So let me write the class first. So what I'll do is I'll create a new class. I'll call this display name bean post processor. Okay, so here I'm going to write code to print the bean name. So in order to make any class the bean post processor, I need to implement the bean post processor class. Okay. Now this, let me import this first. This is from the beans factory config package. Okay, so when I implement the BeanPostProcessor, there are a couple of methods that I'll have to write. So if I add the unimplemented methods, you see here there are two methods that Eclipse comes up with. Now these two methods are again callbacks for Spring to call when each of the beans are initialized. So you have two methods here. One is the post process before initialization and a post process after initialization. Note that these two methods take two arguments. One is the object and one is a string. And even this method takes an object and a string. So what's happening is before initializing any bean, this method is called, okay, and then after completing the initialization, after doing all the dependency injection and all that stuff, this method is called. And the arguments that are passed are, the first argument is the object, which is the bean object itself. And the second argument that's passed is the name of the bean as configured in the Spring XML. So again, the same here. The object is passed and the name of the bean is passed. And both these methods have a return type as an object. So Spring expects you, if you implement these methods, Spring expects you to return the object back so that it can continue its configuration using the object that you're returning. So what happens is, let's say you're getting an object over here. You need to make sure that you're returning the same object. You might want to make changes to the object. Again, it depends on your configuration needs. But then once you're done with it, you're supposed to return the object back. Otherwise, you're going to break this flow. So here what I'm going to do is I'm going to implement the post process after initialization. Or why not implement both? I'm going to change this. I'm going to remove this piece of code here. So the first thing I'm going to do is I'm going to print a statement. System.out println here in before initialization method, bean name is, and I'm going to print out the bean name. Let me name this right. So this is the actual bean, and the string that we're getting is the bean name. So I'm going to print out this bean name here. Okay, so let me print the same thing here. Of course, I'm going to change the message. This is after. Now note here that it's throwing an error because it's returning an object and I haven't returned anything. I need to make sure that I'm returning the bean that I'm getting here. So I'm going to return bean. And even here, this is the bean and this is the bean name, and I'm going to return the bean. Note here that you can return any object you want and Spring is going to take that. So you have full flexibility here. You can make changes to the object that you're getting. You can return a different object. So all these things are possible. But here in this particular scenario, I'm not making any changes to the bean object itself. I'm just taking the bean name that I'm getting and I'm printing out a message over here. So let me save this. So here I have created a BeanPostProcessor. Now what I need to do is I need to tell Spring that I want this to be registered as a BeanPostProcessor. Just having a class that implements a BeanPostProcessor is not enough. Spring needs to know that you want this to be in action. So what I do is I go to the spring.xml and I define this bean over here. So I'm going to say bean class equals, and the class here is, of course, the package name dot display name bean post processor, and that's it. This is all it takes. Note that I'm not creating an ID here because this class is not referenced in any other class. No class is actually dependent on this class. You wouldn't want to do a get bean of this, and you wouldn't want to have some other class having this as a dependency. So since I don't have a dependency, I'm not giving it an ID, and I'm not doing any configuration as well. I'm just letting Spring know that I have a bean like this here, and rest is automatically deduced by Spring itself. It knows that this class implements BeanPostProcessor, and it has these two methods, so it's going to call these two methods. So this is all it takes in order to have a BeanPostProcessor. Now note that I can have any number of such classes like this. So this is just a display name. I can have any other number of classes, and then I can have all of them implement the BeanPostProcessor. And you can even have them implement the ordered interface so that you can have an order property, and then you can specify the order in which Spring executes. But in this example, I'm going to keep this simple. I'm just going to have one BeanPostProcessor, and then I have defined both the before initialization and the after initialization methods. I'm just printing out the name and then returning the bean that I'm getting. So let's see how this works now. I'm not gonna make any other changes. Okay, I'm just gonna call the get bean as usual, and then the dependencies are set here as usual. No other changes to the existing code. I'm just plugging in this new functionality, and then this functionality gets executed before and after initialization of each and every bean here. So if we run this, well, there you go. You can see there is a before initialization of point A, after initialization of point A, before initialization of point B, after of point B, before of C, and after of C. So these are the first set of objects that get initialized. And after that, you can see before initialization of triangle, after initialization of triangle. Of course, we had to have these three initialized first because triangle is dependent on these three objects. So after triangle is initialized, that's when the flow of execution continues. You have point ABC prints. So what's happening here is these two methods are being executed for the initialization of each and every object that you have defined over here. So this is a very handy feature if you want to override some of the default functionalities of Spring, or you want to write your own configurable piece of code that gets executed on each and every bean initialization. Note that there's no destroy here. You cannot have a common class and a common piece of code that gets executed on the destruction of each and every bean. This is for initialization. And again, as I said, this is very helpful if you want to make configuration related code overrides.